Hi everyone, welcome to G World of Academic Physics. In our previous part 1 of the conductors, we discussed some of the basic properties of the conductors. Today, continuing that sections, let me where I have left that left part I will consider again. This is my neutral conductor. This is my neutral conductor. And I said exactly certain distance d there will be a charge q. Points have been mentioned. This is point B, this is point C, and let A be this point. The question I asked, write the potential. This is a sphere of radius r. Find the potential of C. Write the potential of C. This kind of one question I did. Let me one more time I will do so that student can easily get these things. I said this is a neutral conductor. Due to this charge there will be some induced charges. So what will happen? Negative charge will be this side and positive charges on this side of the conductors. So definitely like this in discuss. And I know conductors behaves like an equipotential surface. So potential of B is nothing but potential of C. What is the potential of B? Potential of B is due to two charges. One is this charge and due to induced charges. Due to charge Q, which is external charge, plus due to all the induced charges potential. So potential of B is due to sum of two potential. One is the charge which is external charge, another one is induced charge. But this is pretty clear that due to induced charges the potential is 0 because these charges and these charges symmetrically arranged and the distance remain r. So the potential will be 0 because they cancel each other. If I will consider due to this section the potential is negative and due to this section the potential is positive. So induced they can cancel each other. So potential of B is nothing but potential due to this Q charge, and this is a point charge. At point charge at point B, what is the expression of potential? I know the potential expression due to a point charge is kq upon r. Kq the charge and r is what distance? This distance d. This is the potential of B. I know potential of B equals to potential of C. So potential of B is nothing but potential of C equals to kq upon d. So this is pretty clear. If someone is asking what is the potential at point C, if a charge is lies outside, what is the expression of potential? My answer is kq upon d. In this question, if I'll add one more section, they can ask the question, what is the potential at point C due to induced charges? Potential at point C is how much due to induced charges? This is a little good question, a small format, basic format they can also ask. Potential at C due to which charges? Induced charges. Let me know the concept that potential at B is equals to potential at C because conductors behaves like an equipotential surface. So potential at B equals to potential at C. Potential at B due to how many charges? Due to two charges. One is external charge and due to induced charges. So potential at B is due to external charge. Sorry, this is not arrow mark, sorry. And potential due to induced charges. Due to induced charges. Similarly, potential at C also due to this charge and induced charges. Potential due to Q, that is external charge, plus potential due to induced charge. Potential at C due to induced charge. Because this charge having role always is there, one is external charge, another one is induced charge. If you observe this section, the induced charge at B cancel each other because this point equally distance it will be placed because here it is r, here also it is r. So definitely potential due to induced charges at point B is 0. Potential due to induced charges at point B is 0 because this point equidistance this point to all charges and symmetrically charges are arranged on both the sides, both the surfaces of the sphere, so that's why they cancel. And potential due to charge Q, what is the expression of potential at point B? The point charge expression is kq by d. Is nothing but potential at C point due to this charge. This is d, this is r, and I can say this distance is d square plus r square root over. And if I write my potential at point C due to this external charge, I will write kq upon this distance, because always I will consider the point where it is asking if you will go for the expression of electric field of the potential, the expression is kq upon r. R is which distance? This distance, because this point it is asking, so this distance I will consider. Kq upon d square plus r square root over plus induced. And question is asking find the potential due to induced. So it is obvious that potential due to induced is nothing but this charge minus this charge. Potential of induced is nothing but what? This charge minus this charge. So this is my desired answer. Potential at point C due to induced charges. What is the expressions? This is my expressions. The student must be aware about this thing. This is root over. One thing I missed. This is root over. One more time I want to explain to the student that if someone is asking you find the expression of the potential at point C due to which charges? Induced charges. What I will write? I know the potential of B equals to potential of C, because conductor behaves like an equipotential surface. Everywhere the potential remains same. And potential of B is due to how many charges? Due to this charge and due to induced charges. So write this charge, external charge and induced charge. Similarly, potential at C due to how many charges? One is this charge and due to induced charges. But due to induced charges, potential at B is 0. Why 0? Because they are equidistant and symmetrically arranged. That's why it is 0. And this is a point charge. Point charge at certain point B. What is the expression of potential? The potential is kq upon d. And due to this external charge at C point, what is the expression of potential? I write my potential. And question is asking due to induced charges, what is the expression of potential at C? Due to induced charges, I'll get directly the expressions like this. Similar fashion, if I'll consider one more questions, this is my questions. This is a sphere, neutral conductor, you can say, neutral conductor. This distance, I will consider this distance as 2r. And this is exactly center, you can consider. This is C point. This is A point where a charge Q is present. The question is asking a point B, which is at what distance? I will consider this distance as r by 2. I will consider this distance. Okay, better use. I will consider this distance as r. The question will ask you find the potential at B. Find the potential at B due to induced charges. Due to which charges? Induced charges. Due to which charge? Induced charge. Find the expression of potential due to induced charge. I know due to this charge influence, the negative charge will accumulate on this side of the surface and positive charge will accumulate on these sides of the surface. That previously we have discussed these things. And I said this radius, this is 2r, this is r. Okay. Let's come to the point. I know the potential of C and the potential of B remain same because conductor behaves like an equipotential surface. So potential of C and the potential of B remain same. The potential of C is due to how many charges? External charge and the induced charges. So potential at C is due to external plus potential at point C due to induced charges. Similarly, the potential at B is due to how many charges? Due to external and all these induced charges. At B is due to external and plus induced charges. This is a similar fashion because potential when you are finding, we are looking for all charges. Due to external charge, potential at C, this is a point charge and how much duri? 2r. So expression is kq upon 2r. What is the induced potential? This is negative, this is positive, but equidistance to this point because exactly at the center. Here how much duri? Here also how much same distance is there. That's why this is cancel each other. This potential is 0. Potential due to external at point B. This is 2r, this is r. So total distance is how much? 3r. And I know the expression due to a point charge. This is kq upon 3r. And due to induced, this is my induced. So this is pretty clear that potential due to induced charges at point B induced charges, this is due to point B, this is due to point B, and this is due to point C, and this is due to point C, and due to C it is cancelled out. Due to induced at point B is nothing but kq upon 2r minus kq upon 3r. So this is the, if you make a common kq upon r, this is 1 by 2 minus 1 by 3r. If I little proceed quicker, this is 2, 3, LCM is 6, this is 3 minus 2, and you will get kq upon 6r. This is my final expression of the potential due to these induced charges. If any induced charges question is asking to us, this basic things must be strike to in our mind, that I'll write the 2 points potential. Always look at the center point and write the center point and the other point where the asking due to induced charges, and go through proceed in the similar fashion, one can reach to the conclusion. This is the fifth number properties that we have discussed, that electric field due to induced charges is negative of electric field due to external. This is one concept based on that. The second most important concept is that suppose this is a new conductor and this is also a spherical conductor. These are two spherical conductors. Let me see the questions little. Yes, this is a spherical conductor, this is a spherical conductor, this is radius is r, and suppose this radius is 2r. Anything you can prefer like this. Two spherical conductors have been there and they have connected like this. Here the charge is q and here the charge is, you can say, 6q. Anything you can prefer like this. And these two spherical conductors, a large distance can be apart. The question can be asked you that how much charge will flow from one conductor to another conductor. What is the sixth number property says? If two conductors are connected through a conducting wires, if two conductors have connected through a conducting wire, charge can flow from one conductor to other conductor until unless the potential of the two conductors remain same. If the potential of this conductor remain potential of this conductor, then charge flows can be stopped. Till now the charge will flow from this conductor to this conductor, or either this conductor to this conductors. So this is obvious, this is a very major property of the conductor. When two conductors are connected through a connecting wire, charge will flows from one conductor to other conductor, and this is a very major property. If positive charge, it is flows from higher potential to lower potential. If it is a positive charge, it is flows from higher potential to lower potential. This is a very quoted statement, please in the mind. Let me consider a conductor. This is a conductor. The radius of the conductor is r, charge is q. There is another conductor. I said the charge is 2q and the radius is 4r. And these two conductors are connected by a conducting wire. Then what will happen? The charge will flow from one conductor to another conductor. This is my conductor A, this is my conductor B. The question can be framed, how much charge will flow from one conductor to other conductor? This is one question. And what is the final charge after charge flowing from one conductor to other conductor? How much charge accumulate after flowing one conductor to another conductor? How much charge accumulate on each conductors? So this is a basic concept student must be in the mind, that charge always flows from higher potential to lower potentials. Positive charge always flows from higher potential to lower potentials. I will think about the potential of this sphere. What is the potential of this sphere? The potential expression is kq upon r. And what is the potential of this sphere? The k 2q upon 4r. And what is the expression is coming? K q upon 2r. And this is what? Potential of A, and this is what? Potential of B. Whose potential is more? Kq upon r. This is kq upon 2r. So definitely potential of A is greater than potential of B. If potential of A is a higher potential, potential B is a lower potential, definitely charge will flow from this potential to this sphere to this sphere. So definitely charge will flow from point A to point B. If this is true, How to approach this question? This is the preliminary information a student must be gathered, that charge flows from higher potential to lower potential, and I will check the potential of this, I will check the potential of this, and I will observe that potential of A is greater than potential of B, because expression of the potential is kq upon r, here expression is kq upon 2r. How much charge flows? Suppose charge will flow until the potential of both the sphere remains same. So when I will say certain amount of charge flows from this q and accumulate here, this q, this 2q. It means I said q amount of charge flows and q amount of charge is added here. And this flows up to what extent? When the potential remains same. So if charge removed from this section, its final charge is what? Q minus q, and its final charge is what? 2q plus q, because charge is coming and added here. And up to what extent this charge will flow? Till the potential of this and this remains same. This is my initial charge, this is my final charge, this much of charge flows. I will write the potential of A. What is the expression of potential of A? This is k q minus q upon r, because radius is r. What is the expression of potential B? This is k 2q plus q upon what? 2r. This is the potential of B. And both the potential remain same, up to that extent charge will flow. So that's why potential of A equals to potential of B. And what will happen? I will make it equal k q minus small q upon r equals to k 2q plus q upon r, and k r have cancelled out. This is 2r, sorry, the radius is 2r, r cancel out. And what is the expression is coming? This is little solve things necessary. If you solve these things, this is q minus q equals to 2q plus q, and 2q, this is q equals to what? Capital Q is coming what? This is 2q, here minus q, here q, this is 2q. So capital Q is coming as 2q, capital Q is coming as 2q. So small q equals to what? Q by 2. Small q value is what? Q by 2. So how much charge flows? Q by 2 charge has flown from this conductor to this conductor. So what is the final charge? Q minus Q by 2. This is Q by 2. And what is the charge on this conductor? The charge on this conductor 2q plus Q by 2. This is 5q by 2. I hope this scenario is pretty clear. 2q plus q by 2, so this is 5q by 2. So final charge on this conductor one can easily predict. This is q by 2 and this is what? 5q by 2. I hope this scenario is pretty clear to everyone. One more illustration I want to make it so that student can easily avoid. I will consider this is my spherical conductor, this is another spherical conductor, and here it is 5q, here it is what? Suppose I will consider minus q. And how much, and I will say they are connected through a conducting wires. These are connected through a conducting wires. Here the radius is r and here the radius is what? You can say the radius is, I will simply write the radius is what? Let me see what is the radius, 3r. Make it plus q. Okay, I am considering this is plus q, this is also plus q. Here radius is r and here the radius is 3r. I simply connected these two conductors. Let me check the question is correct or not. Yes, these are questions. I will check first how much charge will flow. First check the potential. The potential of A is what? K 5q upon r. And what is the potential of B? This is K. Here it is capital Q, better to prefer like this. So K q upon 3r. If you observe very carefully, the potential is kq upon r, this is 5 kq upon r, and this is B is what? Kq upon 3r. So which one is bigger? This one definitely bigger, this is smaller. So charge will flow from higher potential to lower potential. Definitely charge will flow from higher potential to lower potential. And second most important thing is how much charge will flow? I will say initial charge was what? Plus 5q, and it is flows. I will say some q amount of charge flows from this conductor to this conductor. So now it is final charge is what? 5q minus q. And what is the final charge? Plus q plus q. If I will write the potential of this and this, what will happen? I'll write the, because up to what extent charge will flow, this is final situation where the potential of A equals to potential of B. Up to that extent the charge will flow. I'll write, simply equate the potential of this. So K 5Q minus Q upon this radius was R and this radius was 3R. So this is R, this is nothing but K, Q plus Q upon 3R. Cancelling the fact, what are the things have been coming? So 15Q minus 3Q equals to Q plus Q, and little arrange, this is 4Q equals to what? 14Q, and Q is coming 14 but a 4Q. This is you can say 7 upon 2Q. This is my final answer. This much of charge flows. If this value is what? 7Q upon 2. If this charge is flows, what is the final charge of this and this pair? This pair 5Q minus Q. So 5Q minus 7Q upon 2. So this is definitely 3Q upon 2. This is the final charge on this pair. And what is the final charge on this pair? Q plus Q. So Q plus 7Q upon 2. So this is nothing but 9Q upon 2. This is the final charge is accumulated on this surface of the conductor. I hope this section is pretty clear to everyone. If this kind of question is asking to us, if two conductors are connected and through a connecting wire, so definitely charge will flow from one conductor to other conductor. Up to what extent charge will flows? Charge will flows till the potential of the two conductors remain same. So definitely, if I will check first the two conductors potentials, which one is greater potential, which one is smaller potential. Charge definitely flows from higher potential to lower potential, and I will, after removing the charge, what are the final charges, make the potential of the two equal, and you will get the result. Little more property if I will go for the conductors, that is called earthing of the conductor or earthing of the conductors. Earthing of conductors. What will happen? Suppose this is a conductor and this conductor is earthed. This conductor is earthed. It means this conductor is connected to earth. Suppose this is earth, means if I will redraw these things, suppose this is a R-shaped conductor, this radius is R, and it is earthed, means it is nothing but it is connected to what? Earth. It is connected to what? Earth. So what will happen when a conductor is connected to earth? The potential of the conductor is 0. This is one more major property of the conductor. When a conductor is earthed, the potential of the conductor remain 0. Suppose a conductor, charge Q is on the surface of the conductor. Now I will simply connect it with the earth. So what will happen? Charge will flow. Charge will flow. Suppose I will say Q amount of charge will flow, because higher potential and lower potential, definitely charge will flow. Let me check the potential of this conductor. What is the potential of the conductor? This is KQ upon R. And what is the potential of the earth? The potential of the earth, the radius of the earth is nothing but 6400 kilometer, something like that. So definitely potential of this conductor is greater than the potential of the earth. If I look at the radius of the earth is 6400 kilometer, something like that. So definitely the R value is very large. In case of potential of earth, we don't know, some value will be there, and this is earth. So definitely this radius is very much, so potential this is higher potential, this is lower potential, so charge will definitely flows from here. It's like a prediction that we have counted here. If I will write for potential, suppose Q amount of charge flown, so up to what extent charge will flow? When the potential of the both the conductors remain same, because earth itself also a conductor. Suppose Q amount of charge flows, then what is the final charge? Q minus Q. And suppose Q amount of charge is added here. If you observe very carefully, the potential of conductor equals to what? Potential of earth. Potential of the conductor after removing Q charge, up to what extent? When the potential remains same, this much of charge is flown. So K, Q minus Q, radius of the conductor. And what is the earth conductor? This is K, small q, and this is what? radius of earth. What are the things have been cancelled out? K cancel. What is the expression we are getting? Q minus Q into earth. Radius of earth is nothing but Q into R. Little arrangement here. Q into radius of earth equals to what? Small q radius of earth plus q into r. Little arrangement if I will do here, the expression of q is coming q radius of earth upon what? R earth, radius of earth plus radius of the conductor. This is the expression is coming out. So final expression I want to write, q is nothing but q radius of earth upon what? R plus radius of earth. This is the charge flown from one conductor to the earth if it is grounded. If I will consider the radius of the earth is very large, what will happen? The small r is very negligible. Q equals to what? If I will say radius of the earth is much more greater than the radius of the conductor, in that case Q r earth upon what? R earth, because this things is negligible and what is happening? Q. So how much charge is flown? So Q amount of charge is flown. That is you concluded here. How much charge has flown? How much charge has flown? This is Q amount of charge has flown. Usually what student feel in these questions, if you observe little carefully, I will draw here. This is my conductor and this is grounded, means it is connected with earth. The radius is r and I found that this small value is capital Q. How much charge initially on the surface of the conductor, these things, how much charge flows to the earth, this is Q amount of charge. It means all the charge is flows to the conductors. This is only possible if I will make a assumption that radius of the earth is much more greater than the radius of the conductors. But if I will consider this R, then actually all Q amount of charge is not flows to the conductor. There will be some amount of charge flows to the conductors. This is most ideal case. If I will consider, if I will approximate it, if I will consider the radius of the earth is much more greater than R, then I remove the R and I said all Q amount of charge flows. But in real practice, this R having some existence, though definitely this small q cannot be equals to capital Q. So this is a concept. Usually students do the mistake that if a conductor is earthed, all charge flows to the conductor. No, all charges may or may not flows to the conductor, but potential of the conductors is 0. This is the important concept. If it is earthed, potential of the conductor is 0 rather than charge of the conductors, Those students have a little doubt, they can be benefited through this. Here we proved these things that yes, the conductors, if you will assume that earth radius is much more than the radius of the conductor, then we will consider that all charge flows. But in real practice, that all charges may or may not be flows to the earth, but potential of the conductor is 0. The earth arranged in such a fashion to the charge so that the net potential of the conductor remains 0 if it is earthed. This is a very important conclusion for the student perspectives. Let me one more time. If something is earthed, I know the potential of conductor, I know the potential of earth, and it is obvious that the conductor of earth, this conductor potential is more than this earth. And up to what extent charge will flow? Till the potential of these two conductors remains same. And I said the conductor conduct Q amount of charge flows, so Q minus Q is the final charge. Here Q charges is added. And similar fashion, if I will go for the conductors, I reach to the conclusion that Q equals to Q earth upon R plus R earth. Here the approximation case we have considered very much more greater than R. So that's why I ignored these things and I said all charges flows to the conductor. All charges flows into the earth when it is grounded, if the conductor is grounded. But in real practice, all charges may or may not flows because these are having some impact, but potential of the conductor remains 0. I hope those who have been watching these things, they will be little benefited. And if you understood and if you like it, please share and subscribe the channels. I hope all will be benefited. Thank you everyone. Thank you for your watching.